Welcome everybody. I'm Mariam Tabana, a student in Faculty of Pharmacy, Munifia University. I'm gonna talk today about my biochemistry project, supervised by Dr. Muhammad Badr, under the auspices of Biochemistry Department in our faculty. I'm gonna talk today about protein sequence alignment. So let's know first what's sequence alignment. Sequence alignment is a way of arranging sequences of DNA, RNA, or protein to identify regions of similarities. The sequence alignment can be made between a known sequence, which is a reference, and an unknown sequence, which is a query sequence. There are two types of sequence alignment, global and local. We're gonna deal with local alignment. So let's now see the steps. First of all, we're gonna open Google, and then we will write NCBI. NCBI is an abbreviation for National Center for Biotechnology Information. Okay, and here we're gonna choose BLAST. Okay, BLAST is an abbreviation for Basic Local Alignment Search Tool. BLAST helps to find regions of similarities between biological sequences, and it compares nucleotide or protein sequences to sequence database. As we can see here, there is nucleotide sequence, nucleotide plus. It's searching a nucleotide database using a nucleotide query, and the BLAST-X it search protein database by using a translated nucleotide query, and the T+N search translated nucleotide by using search translated nucleotide database by using a protein query. And the protein plus here it search a protein database by using a protein query. I'm gonna choose protein plus as I want to compare the unknown protein with a known one. Okay, in this box we will write the sequence of amino acids. Wait a moment. Here's our sequence, copy. And then we're gonna paste it in this box. Okay. And here in database, we will choose non-redundant protein sequence. And in organism, I will not choose anything as I don't wanna restrict my result on only one organism, and I want it to be wide results. Okay, and here I'll choose B plus or protein plus, and then we will click on plus. Okay, it's loading, and wait for a moment. I'll get the results. Okay, here are our results. As we can see here, the job title is protein sequence, and the description is none. This means that my protein hasn't been discovered yet. And the molecule type is amino acid. The query length is 346 amino acids. This means that my protein consists of 346 amino acids, okay? Wait a moment. Okay. Here in the description, we can see that the sequence is producing significant alignment. This means that the unknown protein shows similarities with two proteins present in nature. These proteins are the predicted protein and the low-quality protein. First of all, the predicted protein, the E value or the expect value is 4.2, and the low-quality protein, the expect value is 6. The percent identity of the predicted protein is 34.21%, and for low quality protein is 40.35%. Okay, let's return back to here to see. Okay, this is the graphic summary of my unknown protein in comparison with the known protein. Okay, and this is the alignments. As we can see here, for predicted protein, the identities is 39 amino acids per 114 amino acids, shows 34% similarity. And for positives, 53 amino acids per 114 amino acids shows 46% similarity, okay? And in low quality protein, The identities here is 23 amino acids per 57 amino acids, shows 40% similarity. And the positives, 31 amino acids per 57 amino acids, shows 54% similarity. Okay, here. So we have finished the first step. Oh, wait. Here in the taxonomy, the predicted protein and the low quality protein. Predicted protein is found in Nematostella victensis, which is the sea animals, and the low quality protein is present in Cotoperca gopu, which is a pony fish. Okay. Now we've finished the first step. Now we want to see the 3D structure, or we want to make a model for our protein. We will open again Google, and then we will write Swiss model. Okay. We'll click on Start Modeling. We will paste here the sequence of amino acids. Okay. And then we will click on Build Model. Wait for a moment. A Swiss model will give us the unknown protein have how many templates and how many models. Okay. Okay, as we can see here, it gives us 6 templates, and the models is still searching. Okay, my unknown protein have 6 templates and 3 models. Let's see the templates. Here are the templates of my unknown protein: serine threonine protein kinase and beta xylosidase per alpha and lectin-like fold protein. Okay, here are the 6 templates, and here are the 3 models. The first model, the GMQE, is 0.03, and the sequence identity is 20.59%. Okay, let's see the structure of the first model. Here the structure of the first model is present in many forms. This is called cartoon form, and this is called ball and stick form. These balls represent the amino acids, and the bond between them is the peptide bond. Okay, here's the licorice form, and here is the space fill form. Okay, this is model 1. Now let's see model 2. Model 2, the GMQE of model 2 is 0.03, and the sequence identity is 9.09%. Let's see the structure. Wait. Sorry. Here's the structure. Sorry. Okay. Here is the space fill structure. Wait. And here is the ball and stick structure of model 2. This is the rope structure, licorice structure, licorice form, and space fill structure. Okay. Now let's see model 3. Model 3, the GMQE is 0.03, and the sequence identity is 39.29%. And the structures, this is the space fill structure, the cartoon structure, the ball and stick structure, and the licorice structure. If you want to know the aliphatic amino acids present in our protein, here we will choose aliphatic, And then here, we'll go back to the structure. We will see that the aliphatic amino acids are represented by a blue color. Here are they. Okay, let's see it in ball and stick structure. Okay, if we want to see the proline amino acids, for example, okay, they are also represented in blue color. Here are they. We can see it in the cartoon form. Okay, now we want to know what will happen to our protein, to the Swiss model, and to the similarity of our protein if we have made some mutation in our protein. Okay, we'll go back to Google, and then we write BLAST. We'll choose protein BLAST, and here we will paste the sequence after mutation, after removing some amino acids from our main amino acid sequence. Okay, this is the sequence after mutation. We will paste it here. And then the same steps, we'll click again on BLAST. Okay, it's loading. I'll show you the results. Here are the results of our protein after mutation. Job title, protein sequence, and description none. Molecule type, amino acid, and the query length is 326. I've removed approximately 20 amino acids from the main sequence of amino acids of my protein. Okay, as we can see here, there's no significant similarity found. This is the difference between the protein before and after mutation. Before mutation, there was similarity with other proteins or known or common proteins, but here there is no significant similarity. Okay, now let's see if there will be any difference in Swiss model. Okay, Swiss model, start modeling. We will paste the sequence after mutation here, and then we will click on build model. Okay. Okay, as we can see here, there are 5 templates for our protein after mutation. And how many models? Okay. Okay, there are 5 templates for our protein after mutation and 4 models. Before mutation, there were 6 templates and 3 models. As we can see here, this is model 1. Okay, this is model 1. The GMQE is 0.05 and the sequence identity is 8.06%. Okay, let's see the structure of model 1. This is the structure, that is the cartoon form. It's somehow different from the protein before mutation. And this is the ball and stick structure, of course different. And this is the space fill. Okay, let's see the second model. Here's the second model. The GMQE is 0.03 and the sequence identity is 6.82%. Let's see the structure now. Okay, this is the space fill structure. This is the cartoon structure of model 2. And this is the ball and stick structure. Now let's see model 3. Okay, Model 3, the GMQE is 0.03 and the sequence identity is 9.09%. Now let's go to the structure. Oh, this is the ball and stick structure. It's different, of course. This is the space fill or the bulky structure. And this is the cartoon structure. It differs from Model 1 and Model 2. Okay. Now let's go to the Model 4. Here is it. Model 4, the GMQE is 0.02 and the sequence identity is 21.43%. Let's see the structure now. Here's the cartoon form, the lines form, the ball and stick form, and the space fill form. Okay. If we want to see the aliphatic amino acids present in my protein after mutation, I can go back here. Sorry. We will choose aliphatic and then we'll go back to the structure. We will see that the aliphatic amino acids are represented by the blue color. Okay. If we want to see this, the proline amino acids, for example, here we'll choose proline, and then we return back to the structure, and then it's also represented by blue color. We can see it in the licorice form, the space fill form, and the cartoon form. Now we've seen the difference between our protein before mutation and after mutation. We've reached to the end of our video now, and thanks a lot for watching.